All right, so last day of our pre-algebra review, day 4, variables and expressions. I really like this stuff too. You'll find that when I teach, I like a lot of stuff. I can't help it. I'm a nerd. Just bear with me. But I really like this lesson. I think it's fun. I like these problems. They're like puzzles to me. Okay, so first let's talk about powers of a power, or product of a power property. So you may not have seen this, but it's okay. I'm going to teach you now. So a to the m times a to the n equals a to the m plus n. It's a plus sign. Why? Okay, so you're like, what are you talking about, Mrs. Roeder? I know, I get it, but it really works. So let me give you an example. If I had a squared times a to the third, well, via this property, it would be a to the fifth. Why does that work? Because this is like a times a times a times a times a. That's 1, 2, 3, 4, 5 a's, so that's a to the fifth. So it does work, okay? It does work. And all of these today that have numbers and stuff, I want you to just leave them as, or right at this part, I want you to just leave it as something to the something power. Just leave it in the power format. You don't need to multiply it out. Okay, so this one's y times y to the sixth. A lot of people want to say, well, the answer is y to the sixth. No, it's not. Because remember, this is like y to the first times y to the sixth, which would be y to the seventh. If you ever get confused, when in doubt, write it out. Always. When in doubt, write it out. On a lot of these, that helps you. So you got y times 1, 2, 3, 4, 5, 6. So that was this y to the 6 times the other one. That gives you 7 y's. All right? What will this next one be? 2 to the third times 2 to the third? 2 to the sixth. That's it. No big thing. Negative 2 times negative 2 to the fourth. Remember that negative 2 is like, the first one is like negative 2 to the first power. So this will be negative 2 to the fifth. That's all. Next one is a little bit trickier. Don't freak out. You can do it. So first let's talk about the x's. Actually, let's write it out because it looks a little bit from here. Let's just write it out so you make sure you understand it. We've got 6 times 1, 2, 3 x's times 7 times 1, 2 x's. All right, so let's multiply the 6 and the 7 first. 6 times 7 gives you 42. And then x times x times x times 2 more x's is x to the fifth. And that's your answer. That's it. That's all you got to do. All right, let's talk about division. So whenever we were multiplying them, we added the exponents. What do you think we do when we divide them? Hopefully you thought subtract. If not, it's okay. So this is going to say x to the m minus n. That's a minus sign. Why does this work? Well, let's talk about it. So if I have x to the third divided by x squared, this would be 3 minus 2, which would be x to the first power, or just x, right? Well, let me prove to you that it works. When in doubt, write it out. Got 1, 2, 3 x's on top, 2 x's on bottom. Let's see if they crosses out. They do, so this cross cancels, this cancels, and what are you left with? 1x in the numerator, so that's just x over 1, or x. So it does work. Okay, so 7 to x to the 7th divided by x to the 4th. Well, we know from our property, we just got to subtract the exponents. So this should be x to the 3rd. If you weren't sure, you could, if I'm telling you, if you ever are unsure, please write it out. It makes it so much easier if you want to see it. 1, 2, 3, 4, 5, 6, 7 x's divided by 1, 2, 3, 4 x's. Let's go ahead and cross them off. 1, 2, 3, 4. You're left with the x times x times x, which equals x to the 3rd. Okay? It works. All right, so let's talk about this next one. It's a little different. Okay, I don't know if you've seen negative exponents, but if you haven't, that's okay. If you have, that's okay. We're just going to kind of get used to this at the moment. I'm not going to go into a lot of detail because we'll go into this later. So if I see 5 to the 3rd over 5 to the 5th, well, you know, you just subtract them. And 3 minus 5 is going to be -2. So this will be 5 to the -2 power. Yes, you could have negative exponents. If you've never seen them before, you can have it. It's allowed, I promise. Another way you could write this is 5 times 5 times 5 over 1, 2, 3, 4, 5. Cross them off. And you're left with 1 over 5 squared at the bottom in the denominator. You can leave that as an answer. So I would take either this answer or this answer. Either way, whichever you prefer to do works for me. I'm okay with it. All right, next, so now we have 2 steps. So remember from days, I think it was the first day, whenever you have this, you treat the top and then the bottom and then divide them at the very end. So we can't do anything to the bottom, but we can combine the top. So this is going to be z to the what? 8th. So z to the 8th over z to the 6th equals z squared. All right, when in doubt, if you were confused, please write it out. Please, I beg you. So I've got z on the first one for that z to the 3rd, and then I've got 5 more z's, 2, 3, 4, 5, and then on the bottom I've got 6, so 1, 2, 3, 4, 5, 6. Let's go ahead and cross out what we can. Hey, look at that, we're left with 2 z's, and z times z is z squared. That's the same answer we got. So whichever way is easier for you, do it that way. Okay, same thing with this one. If you want, pause the video, try it on your own. So we've got -5 to the 5th, -5 divided by -5 to the 3rd, and then -5 times -5 is squared. So if I were you, you have to solve the bottom, and then remember, then you do the division. So we add the exponents, so this would be -5 to the 5th over -5 to the 5th. Well, what's -5? You subtract your exponents. 5 minus 5 is going to be -5 to the 0 power. If you don't know what -5 to the 0 power, anything, we're going to get into this later too, anything to the 0 power is 1. Let me prove it to you why it works. -5 times -5 times -5 times -5 times -5 divided by, okay, that one had 3, 1, 2, 3, and the other one had 2, -5, -5. What do you notice? We have the perfect amount to cancel all of them, so you would get 1. -5 divided by 5, -5 is 1. So your answer would be 1 for this problem. A little tricky, I know. Okay, distributive property. This should be old news, but this time we're going to add a little bit or some variables with it. Don't freak out. It's the same thing. You can do it. So we've got a to the b, or a times b. Bring down whatever symbol's in there. A times c is ac. A times this one, ab. A times -c would be -ac. That's it. But this time we're going to have some variables. You can do it. So -2x times x would be -2x squared. Remember, x times x, x squared. -2 times 3, or -2x times 3 is -6x. Can we combine those two? We cannot. I'll get into that a little bit later. You cannot combine those two. That's your answer. Leave it. Okay, and this one's like a backwards one. That's all right. -4y times 4y. So -4 times 4 would be -16. Y times y, y squared. -4y times -3. That would be positive 12y. That's it. Can't combine those, y squared and y, so you just leave it. Okay, let's practice these. So a little bit of everything. If you want to pause the video and try it, you should, then get back to it. So -4y times y is -4y squared. -4y times 3 is -12. Okay, next one. 3 x squared divided by 6x to the 6th. So on this one, you may be tempted to, on this one I'm going to write it out because it's a little funky. 1, 2, 3, 4, 5, 6. So I'm left with on bottom or on top just the 3, right? Well, actually it's not, because you can simplify 3/6, right? Just treat this as a fraction, and that becomes 1/2. So actually on top of this fraction you have 1, and on the bottom you have 2 right here. Don't forget that 2 times 1, 2, 3, 4 x's, so x to the 4th. All right, next one, 3 times 4. You kind of do your coefficients times your coefficients, and we'll get into exactly what a coefficient is. So that would be 12, x to the 3rd times x to the 7th would be x to the 10th. 12x to the 10th, that's it. All right, terms, so that is like, so if we have 5x plus 3 minus 4y minus 7, I'm making it up if you can't tell. This is a term, this is a term, this is a term, this is a term. So a term is pretty much being split up by a plus or a minus sign. That's how you tell what a term is. Coefficients is the number in front of a variable. Always. So number in front of a variable. So if I had 3x, the coefficient would be the 3. Just the 3, not the x. There is never a variable in your coefficient. Always just a number. Constant. So if I have like 3x plus 4y minus 8, this minus 8 would be your constant. It does not have a variable. So it does not have a variable. Let's write that. Have a variable. And then like terms have the same variable to the same power. Okay, so the only time you need like terms is whenever you are adding and subtracting, okay? On division, we can do a little bit more funky stuff, but whenever you're adding and subtracting, you need like terms. It's just like common denominators on fractions. You need a common denominator when you're adding and subtracting, but you don't when you're multiplying and dividing. So kind of try to remember it like that if you have trouble with it. Okay, so same variable to the same power. So if I have like x squared plus 3x minus 4x squared minus 2x. Okay, well my common or like terms would be my x squareds, and then it would also, then that would be one set of like terms, and then my other ones would be my 3x and then my minus 2x. Those are like terms. All right, so next one, 5x squared minus 7 plus 3x squared. So do I have any like terms that I can combine? I do. Looks like only one set. So I have 5x squared plus 3x squared, and we can combine that. 5x squared plus 3x squared, 8x squared. Some people may want to say, oh, it's 8x to the 4th. It's not, because we're not multiplying. If we were multiplying, it would be different. It would be x to the 4th. But since we're adding, you just treat it just like it's a variable, x squared. It's going to be x squared as long as you add and subtract. When you start multiplying them, that's when they start changing their powers. But adding and subtracting does not change the power. Easy mistake to make. Then you have that minus 7. You can't combine it with anything because it's a constant, and there are no other constants. So this is your answer. It's as far as you can get. I know it looks a little weird because you're used to solving for x or having one answer. You don't have an equal sign, so you cannot solve for x. That's it. All right, this next one, negative y plus 11y cubed plus 2y minus 4y cubed. Okay, so I've got my negative y and my plus 2y. Those are like terms. And then I have my plus 11y cubed minus 4y cubed. Let's do my y's first. So negative y, that's like negative 1y. Plus 2y is going to be 1y or just y. Negative 1 plus 2 is 1. And then I have my 11y cubed minus 4y cubed would be positive 7y cubed. That's my answer. I cannot combine anything else. Even though they are the same variable, they are different powers. So you cannot add and subtract them. Leave them alone. and there's no equal sign, so we can't solve. All right, a challenge. I want you to pause the video and try this one. Okay, so let's walk through this. So first, let's solve what's in our parentheses. So well, remember, whenever you have something like this and there's different pieces and it's being divided, you do the top piece and the bottom piece and then divide them at the end. So this one is kind of tricky. So you're going to combine those like terms. So x squared minus 4x squared would be negative 3x squared plus 4x to the 5th divided by 3x to the 5th minus 4x. Okay, so I would be really surprised if you got this one correct all the way on your own, but let's see. So let's, because you haven't seen some like this. So then let's multiply that 3 times the negative 3x squared. So that would give me negative 9x squared plus 4x to the 5th divided by 3x to the 5th minus 4x. Okay, so can we add or subtract combine like terms? No, we can't. Okay, and so this time you might want to start dividing, but remember, if you divide, since we have 4 different pieces, you have to divide from every single one. So what could we divide? Is there anything that we could divide from every single one? Well, let's look at our constant, like those numbers first. We've got 9, 3, 4, and 4. None of the, like we can't divide all of those, like they don't have a common factor that we could divide. So let's look at the x's. X squared, x to the 5th, x to the 5th, and x. Well, what did I say every single time? X, right? There's at least one x that we can divide each one by. Can we divide it by x squared? 2 x's. No, we can't, because this one right here only has one x. It's x to the 1st power. But we can divide each one by x. So this would be divided by x, so this would go away. X to the 5th divided by x would be what? X to the 4th, so this turns into a 4. X squared divided by x would give me x, so this goes away. X to the 5th divided by x, again, would be x to the 4th, so this would be a 4. All right, let's clean it up, rewrite it as our final answer. Negative 9x plus 4x to the 4th divided by 3x to the 4th minus 4. All right, I know it looks a little crazy and you're not used to it, but that actually is your final answer. That's it, that's all you can do. All right, last one, write an expression for the perimeter of a triangle and then evaluate when the x equals 7. So first we have to write the expression. So the perimeter, remember, is the distance around the outside of a shape. So we're just going to add them. 5x plus 1 plus 5, oops, I wrote plus twice. Plus 5x, oh, I didn't, I messed up. Plus 5x minus 1 plus 2x plus 12. All right, so then let's see, what do we have for our common denominators? All of our x's are common denominators. I like to underline and do little squiggles. And then our constants. Okay, let's do our x's first. 5x plus 5x is 10x, plus 2x is going to give me 12x, and then 1 minus 1 is 0, plus 12 is plus 12. All right, so there is your first part of the problem if they wanted you to do. Now you have to evaluate when x equals 7, so let's just plug it in. So we've got 12 times 7, because that 12 times x is 12x, that's how you write it, plus 12. That gives you 84 plus 12, which equals 96. That's your second part of the answer. All right, that's all I have for this video.